Alright, students, Mr. Kutsi here. I'm going to be trying to explain some of the stuff in our section here of the textbook. So section 5.5, what we call multiple angle and product to sum formulas. What the hell does all that mean? Well, let's explain. Multiple angles means a multiple of an angle. So like sine of KU means sine of like 3U. Or so let's say you knew 45 degrees. What if you wanted 3 times 45 or 7 times 45? Things like that. So like for example 90 degrees, you could split up 90 as 3 times 30 and solve it that way. And you're gonna be like, well, why would you want to do that? Well, there's gonna be situations where we have to push things around and things like that. Alright, so sine squared, sine of a half angle and stuff like that. A couple formulas, and then some of the solving stuff. So what we're gonna do right now in this video is just sort of go over what the hell does it all mean, how can we solve it all, and what's the difference between different things we were doing. Let's back this up a step before things get too confusing. Your triangle, opposite, adjacent, hypotenuse. Okay, so sine is still a ratio of opposite over hypotenuse. That is still true. What the hell are we doing here? We're moving away from the triangle altogether, and we're just going to push around equations. Okay, so for me, I kind of like when you can draw a triangle and stuff like that. A lot of these things, sine squared, I won't be able to draw a triangle. Like, how do you square a triangle? Well, the geometry, I think, would make it more confusing than just pushing it around. Next thing, where the hell do these things come from? Double angle formulas and things like that. So where the hell did this thing come from? That I can actually show you. Okay. So let's start from yesterday's thing. Let me move this up a little bit. Reposition this. Give me a second here. Okay, so let's back it up a step. The sum and difference formulas. That one said like sine of A plus B is sine of A cosine B plus cosine of A sine B. Okay, that's what the formula was from yesterday. What we got here then is sine of 2u. Okay, so what it is let's replace A and B with u. Alright. If we replace it with u, then this equation becomes this. Let's focus that maybe if we can. Okay. So, what happened here? Instead of A and B, we put u and u, so this becomes this. Well, sine u, cosine u means sine of u times cosine u. Cosine u, sine u means cosine of u times sine. So what I mean is, let's bring this down. It's the same thing. But let's call it sine u, cosine u. Okay, what I mean is, I just switched the order here. Since it's times, it's like 3 times 4 is 4 times 3. That's all we did. Cosine times sine is sine times cosine. It's just, I re-changed the order. Okay, well, wait a minute. Then, let's see if we can focus this a little bit better. These are the same. Sine u, cosine u, sine u, cosine u. So this is like xy and xy. Well, then it's 2 of them. 2xy, or sine u, cosine u. Okay, so whatever this is, and this is the same, like x plus x will be 2x. Well, sine u, cosine u. So 2 of them together is that. So sine of 2u is that. Because I could write u plus u as 2u, and we did it with our sum formula, and we got this. Now, I'm not going to ask you to memorize these. Very likely you'll have a calculus teacher that makes you memorize them. So this is a way you can generate them. I don't memorize everything. I can get this from memorizing just the first one. All right? And that's what it is in the book. There it is. Now, cosine looks different. Cosine, let's do that one. So, first, let's write down what we had from yesterday. Cosine A plus B. Okay, so this is the cosine formula. It goes cosine equals cosine, cosine, sine, sine. That's the way I remembered it. And if it's plus, it changes to minus. Okay, that's the rule. And the whole idea is, like I said, we didn't go over how to prove this one, but if this one has been proven, it's kind of gnarly proof. But if you know this one to be true, you can find the other ones. So instead of a and b, we're going to use u and u. The variable is irrelevant. You can replace it. Then this would be cosine u, sine u, sine u. What? All right, cosine times cosine is cosine squared. Sine times sine is sine squared. And it's kind of weird because you're like, what about the u? Why isn't u squared? We don't write it that way because you're doing cosine of an angle, u. And the u's are not being multiplied. The cosine operation is being multiplied. U plus u is 2u. So what do we have? Cosine of 2u is cosine squared minus sine squared. There's your formula. You don't need to memorize it. It's in the book. But if you needed to get it, as long as you know the original of this formula, plug in u and you can get this on a quiz or a test in calculus. So that's what those are, okay? That's where they come from. Now, where would they be used? Okay, real quick example of that. We'll go through example 1 of this and see what they have here. I'll try and break it down and see if we can make some sense of it. There's your original equation. 2 cosine of x plus sine of 2x. What the hell? Okay, so first things first, you can subtract on both sides, but then you've got x's on both sides. We actually want this. Now, if you don't recall it, anytime you have x's and x's and you have a 0, a lot of times factoring is going to be one of your options. Okay? It's kind of like if you had x squared plus 7x equals 0. Factoring is your option. If you've got x squared, well, we don't have x squared here, but we have x. We have 2 x's and they can't be combined because one's sine, one cosine. Okay. Key thing there, they cannot be combined. So let's see what the book does. I would say, if we're in this chapter, I don't like sine of 2x. Let's change it to something else. And that's what they did. Okay. So how the hell did they get from here to here? That's the formula right up there from right before in the box. Okay, so that's just sort of like a definition thing. That's the formula. So you replaced it with that. So instead of sine of 2x, you're replacing it with this whole thing. And this is where I mentioned factoring is probably going to come in here. Bam. Like, whoa, hold on. What did they do there? Okay, so let me show you what we did here. What it is with factoring and stuff like that, there's different cases, and you just get used to them the more you practice, and you'll recognize them. I don't expect you to know them all right now. By the time you get through calculus, you'll see these so much. What I mean is, x appears here and x appears here. It's kind of like this. X appeared here and x appeared here, so you'd factor out x and then x plus 7. Well, over here you're going to factor out cosine of x. All right. In fact, they both have a cosine and they both have a 2, so you can factor a 2 cosine, and then that'd be 1 plus 2, right, 1 plus sine x. Okay, so you can factor that out. Okay, so theirs looks a little bit better than mine. What it is, if you distributed it, it would get you back to the start. Okay. Now, here's what we got to do. The whole reason you factor is you can split them into 2 equations. The factors equal 0. One of them equals 0. The other one equals 0. 2 separate equations. How do you solve this? Well, you want to find, you want to get x alone, so you divide by 2 and you get cosine of x equals 0 divided by 2. 0 divided by 2 is 0. So now you're asking, when does cosine equal 0? Okay. And over here, you got 1 plus sine x. You're going to subtract 1 on both sides, and you're saying sine of x equals negative 1. Those are not the answers. We need to now answer these questions. Okay? The book answer just throws these 2 numbers in there and goes, how the hell did you get from there to there? I don't get that. So let's talk about that. So we solved up to here. If you're okay up to here, we're saying sine of x equals negative 1 and cosine of x equals 0. What we're saying is, when is cosine equal to 0 and when is sine equal to negative 1? And again, every point on the unit circle is cosine and sine. So, what does that mean? When would cosine be 0? Well, that would be right here, at that location, because your coordinates would be, sorry, oh, I'm sorry, that's when sine would be equal to 0. My bad. That's why I always have to draw it. When will cosine be 0? Oh, up here. 0, comma 1. Because that's cosine and that's sine. Okay. So when is cosine of x equals 0? At what coordinate do you have a 0? And that would be up here. And that would be at pi over 2 angle. Okay. And there's also another location down here. 0, negative 1. That's again a place where your cosine would be equal to 0. And that's 3 pi over 2. So those two locations. Alrighty. Now, when does sine equal negative 1? That actually happens here also. So this is the second location. So when does cosine equal 0? That's here. 3 pi over 2. When does sine equal negative 1? That's also at this location. Because this is cosine, this is sine. Alright. I'll put together some more videos like these. Hopefully this is a little bit helpful. If it's not, send me an email and I will get right back to you on some more details about how to solve this. Alrighty. See you later. Thanks for watching, guys.